First question is a ray of light traveling in the direction 1 by 2 I plus root 3j. So wave is traveling in the direction of vector A given by 1 by 2 I plus root 3j. Is incident on a plane mirror. After reflection, it travels along the direction 1 by 2 I minus root 3j. So this direction is given by of vector B, that is 1 by 2 I minus root 3j. Here the M is the mirror, plane mirror, and N is the normal on it, and the ray incident along the direction of vector A. And after reflection, this ray is along the direction of vector B. We have to find the angle of incidence. If angle of incidence is I and angle of reflection is R, so by the law of reflection, angle I equal to angle R. This is our equation number 1. From the dot product of two vectors, we know that vector A dot vector B equal to magnitude of vector A, magnitude of vector B, and cos theta. Theta is the angle between the vectors. Here theta is the angle between the vectors A and B. This is the direction of vector A and it is the direction of vector B. So angle between them is theta. A is the magnitude of vector A and it is equal to square root of ax square plus ay square, and it will be equal to square root of 1 by 4 plus 1 by 4 into 3. So it will be simply 1. Similarly, magnitude of vector B will be equal to square root of bx square plus by square. It is equal to square root of 1 by 4 because we can write b as bxi plus byj. Similarly, vector A can be written as axi plus ayj. So bx is 1 by 2 and its square is 1 by 4 plus, and by is minus root 3 by 2, so its square will be 3 by 4. So it also gives 1. Therefore, cos theta will be equal to dot product of vector A B divided by magnitude of A and B, and dot product gives 1 by 2 I plus root 3j dot 1 by 2 I plus I minus root 3j divided by magnitude of A is 1 and magnitude of B is 1. So it will give 1 by 4 using this 1 by 2 and 1 by 2, and remaining is I plus root 3j and I minus root 3j. So it simply gives I dot I plus root 3j dot I, then minus root 3 I dot j and minus 3 j dot j. This I dot I is 1, j dot I is 0, I dot j is 0 and j dot j is 1. Therefore, we will have 1 by 4 into 1 minus 3, that is equal to minus 1 by 2. So cos theta is minus 1 by 2, hence theta equal to 120 degree. And now from figure, we can say that angle I plus angle R plus angle theta is 180 degree. Angle I and R are equal, so angle I plus 120 degree, that is equal to 180 degree, or 2 into angle I equal to 60 degree, or angle of incidence will be 30 degree. So option A is the correct option. Second question is, a tall man of height 6 feet want to see his full image, then required minimum length of the mirror will be. We have already derived that minimum length of mirror required to see full image of the man is h, and it is equal to h by 2, where h is the height of man. Therefore, minimum height of the mirror will be 6 by 2, that is equal to 3 feet. So option B is the correct option. Third question is, If two mirrors are kept at 60 degree to each other, then number of images formed by the image. The number of images formed by the two mirror inclined at an angle of theta is 360 degree by theta minus 1. Here angle theta is given 60 degree. So number of the images formed by the mirrors will be 360 degree by 60 degree minus 1, that is equal to 6 minus 1, that is 5. This is the answer. Similar question is, to get the three images of a single object, one should have the two plane mirrors at an angle of, using the formula n equal to 360 degree by theta minus 1. Here number of the images to be formed are 3. So it will be equal to 360 degree by theta minus 1, or 360 degree by theta equal to 3 plus 1, that is equal to 4, or theta is equal to 360 degree by 4 and it is equal to 90 degree. So angle between the mirrors should be 90 degree. Option B is the correct option. Next question is, a beam of light from the source L is incident normally on a plane mirror fixed at a certain distance x from the source. Suppose L is the source of light and at a distance x there is a mirror. The beam is reflected as a spot on the scale placed just above the source L. So just above it there is a scale. And for this normal incidence I, there will be a reflected ray which will also along the normal, this is the reflected ray R1, and make a spot on the scale A placed just above the source L. Now mirror is rotated through a small angle theta. So this is the new position of the mirror. This is M, this is M dash, and this is at an angle of theta if rotated in anti-clockwise sense. As we have already discussed that if mirror is rotated, the reflected ray is also rotated in same sense, but twice the angle of rotation of mirror. So reflected wave will rotated by an angle of 2 theta, and now this reflected ray is R2, making a spot at the point P. When the mirror is rotated through a small angle theta, the spot of the light is found to move through distance y on the scale. So distance AB is y. Therefore, in triangle OAB, which is a right angle triangle, we can write tan 2 theta, that is equal to perpendicular AB divided by base OA. AB is y and OA is x. And it is given in the question that angle is the small angle, so we can approximate tan 2 theta as 2 theta, and it will be equal to y by x. So theta will be equal to y by 2x. Hence, the angle theta is given by y by 2x, which is the option D. Next question. Two plane mirrors are inclined at 70 degree. Suppose two plane mirrors M1 and M2 are inclined at an angle of 70 degree. A ray incident on one mirror, suppose it incident on the mirror M1 at angle theta. This angle is theta. So it also get reflected at the same angle, that is theta. This is the reflected ray. Falls on the second mirror and is reflected from there parallel to the first mirror. This ray falls on second mirror, and here after reflection it becomes parallel to the first mirror, that is M1. So these incident ray and reflected ray at second mirror makes equal angle at the normal, that is suppose alpha and alpha. Now from the figure we can see that inclination angle is 70 degree between the mirrors, so their alternate angle will be 70 degree, and at point A the remaining angle by symmetry we can say it is 70 degree, and in a triangle this 70 and 70 makes 140 degree. Therefore remaining in the triangle, say OAB, will be 40 degree, and normal at B makes angle theta with the reflected ray. Therefore 40 plus theta will be equal to 90 degree and theta will be equal to 50 degree. So value of theta is 50, that is option D is the correct option. Next question is, two plane mirrors M1 and M2 inclined to each other such that a ray of light incident on mirror M1 and parallel to M2 is reflected from the mirror M2 parallel to mirror M1. It is given that two mirrors M1 and M2, and suppose these are inclined at an angle of theta, which we have to find. A ray incident on the M1 at a point A and makes an angle alpha. This is the incident ray I1, and it gets reflected at the same angle as the angle of incidence, that is alpha. And this reflected ray get incident on the mirror M2 at point B, making an angle of beta with the normal. So the reflected ray from the B get parallel to the mirror M1 at the angle beta with the normal. This is the reflected ray 2. Now in the figure we can see that because R2 is parallel to M1, therefore these are two parallel lines. So corresponding angle will be theta between the R2 and the mirror M2. Similarly, I1, that is the incident ray, is parallel to the mirror M2. So I1 makes angle theta because it is a corresponding angle at the point O with the mirror M1. Therefore, at point B, remaining angle will also be theta by symmetry. And in triangle BOA, this remaining angle will be, because two angles are theta, so remaining angle will be pi minus sum of the two angles, that is 2 theta. And because at point A, angle of incidence equal to angle of reflection, so remaining angles will also equal. That means we can say that pi minus 2 theta will be equal to theta at point A, or pi equal to 3 theta, or theta equal to pi by 3, or 180 degree by 3, that is equal to 60 degree. So option D is the correct option. Next question is, a point source S is placed at a distance L in front of the center of the plane mirror. This is the center of the plane mirror of width D, and D is the width of the mirror, which is hanging vertically on the wall. A man, this is the man, walks in front of the mirror along a line parallel to the mirror at a distance 2L. As shown, the distance over which the man can see the image of light source is. For this we take a limiting point, that is M1, on which a ray incident from the source at an angle of theta. So reflected angle will also make the angle theta. We drop a normal and it meets at a point, say A. The reflected ray meets the path at the point B, and the normal from M1 on the path is C. Angle at C and A are 90 degree, so we can say that triangle SAM1 and triangle BCM1 are similar triangle because their corresponding angles are equal. Therefore, the ratio of the sides will be equal. We can say that SA divided by BC will be equal to AM1 divided by CM1. This implies that SA is d by 2 because S is the midpoint of the mirror. So we can write SA is d by 2 divided by BC. BC is the distance which we have to find, and it will be equal to AM1. AM1 is given L, length between the source and the mirror, this is L, and CM1 is the 2L. So we can say that BC is equal to d by 2 into 2L by L. L and L get cancelled, 2 and 2 get cancelled, so BC is D. Similarly, we take another extreme point, that is M2, and take a ray incident from S on it at an angle of theta. It gets reflected and meets the path at point, say, F. So distance of the F and G will be D, equal to the distance between B and C. And CG is parallel to M1, M2 and equal. Therefore, total distance for which man can see the image of the light source is BF, and this will be equal to D plus D plus D, that is equal to 3D. This is the answer.